Howdy web devs. Been a long time since my last upload. So long I actually managed to grow a beard, so sorry about that. I've got the rare Angular demo for you today. I know I haven't talked too much about Angular on this channel, but my day job is actually on the Angular team, where we've recently been experimenting using LLM tools to develop with Angular. And I put together a cool demo that I wanted to show off. I'm trying to understand how AI tools can integrate with large, complex brownfield web applications, and how they can emulate the way that humans develop software. To set the stage, I have a demo e-commerce application. Sadly, not a real store, but useful test applications. It's not incredibly large, but far from trivial, and which I'm going to use Gemini to modify. Gemini already helped me scaffold out some code for a wish list button on individual products and a component for displaying all wish listed items. Even generated a wish list service for tracking this data. The final step is to connect them together, and that's what I'm going to ask Gemini CLI to do right now. In EC product item, when the wish list is pressed, add it to/remove it from the existing injected wish list service. And we can ignore the rest of that prompt, nothing to see here. Gemini reads the relevant files and then provides some code to call the wishlist service. The snippet is actually a perfectly reasonable approach and looks like it should work fine. Next, it's able to validate this work by opening a web browser. I've configured the Playwright MCP server to give the AI access to a browser where it can fully test and verify its work. Here, it scans the page to look for the wishlist functionality and identifies a test case. It clicks the star button on a shirt and then expands the full wishlist, only to find that it's empty. So Gemini actually correctly identifies this as a bug, but there is no error. It's just not working for seemingly no reason. The AI considers that there might be something wrong with the Angular provider. The next step is that it checks Angular's dependency injection graph. This is using a new MCP tool I'm testing out where the AI consults Angular's experimental MCP server with a new getDiGraph tool. This communicates with the active dev server, which has a connection to the running web application. Based on this, the AI can receive runtime data about the Angular app, such as its dependency injection graph, and this gives the LLM access to a new aspect of Angular applications it normally doesn't have visibility into. The AI immediately realizes something is wrong here, as there are multiple wishlist providers at different locations in the application, and this is likely going to split its internal data across multiple objects. It decides that consolidating these providers into a single location is likely the best path forward. It reads the relevant files and updates them, removing the two existing providers and adding a new one in the app config. It then double checks the DI graph just to see if anything has changed and verifies that these providers were removed. I probably should have listed out the root providers explicitly, but the AI correctly reasons that this must mean that the wishlist service is in the root provider, so it wasn't actually a problem here. It waits for the browser to reload with the new changes and tests the same use case again. It wishlists the shirt and then opens up the full list and observes that the shirt is now present, so bug fixed. It even removes the shirt from the wishlist to test removal as well. Wishlist functionality is now working as expected. So what happened here, and why is this important? Well, the AI followed a very human process in software development. It started with a very straightforward problem: call the wishlist service when an item is wishlisted. Like all the straightforward problems I solve, it didn't really work immediately. Gemini used Playwright's MCP to open up a browser and generate a test case, one that I did not instruct it to do, by the way. It figured out how wishlisting was supposed to work all by itself. And with that test case, it noticed the bug that it had introduced and was able to connect itself to Angular's internals to inspect and debug why that might have happened. Based on this, it hypothesized a new fix, applied that fix, and then retested to validate. This overall process is almost exactly what a human workflow would look like, minus a few Jira tickets. So where do we go from here? I'll admit at this stage, this is mostly a concept. This took a lot of tries to get the AI to do the right thing, and almost certainly would not be a productive use of time at this stage. However, I do expect we'll see AI agents get even smarter over time, and I think there's a lot of potential in more Angular integrations here. As a developer with Angular dev tools, you have access to a lot of internal state about your applications, such as the DI graph, component state, the signal graph, router tree, and just a ton more. If we can successfully expose that same information to AI agents, we can provide them much more context to their debugging problems and enable them to solve much more complex issues. Again, this is all an early experiment. We have no idea how impactful these ideas are or exactly what will become of them at this point. If this sounds interesting to you, Minko Getchev has also shared a browser-first agentic workflow, which you might be interested in. Check out the link in the description to see more about that. Ultimately, I just wanted to share this more broadly with the community to develop in the open, as we love to do on the Angular team. What do you all think? Are you excited about this? What other kind of framework information would be useful to your AI agents? What kind of UX would be useful for your use cases? And how are you using AI tools today? Please let us know. We would love to hear your thoughts. See you next video, hopefully less than a year next time.